right, good morning, students. So last week we talked about the different states of matter, and today we are going to get into how these different types of states can change. So first off, let's just quickly review here on what is matter. So remember, matter is anything that takes up space and also has weight to it. So remember, matter has three forms to it. So we had talked about that matter can be a solid, a liquid, or a gas, and that it can change into any of these three forms. Matter can also be described by its properties, which we're going to talk about in a little bit. And a new word that we're going to learn today is that matter is made up of tiny particles called atoms. So maybe you've heard the word atoms before. So just remember that matter is going to be made up of atoms, and that atoms are smaller than matter itself. So what do we know about solids, liquids, and gases? So first off, solids have a definite shape and a definite volume. So for example, the desk that you write on, it has a definite shape, so when you look at it, you know that it is a desk. And also the chair that you sit in, when you sit in it, you know that it's a chair that's going to support you, and that both of these also have a definite volume. They take up a certain amount of space, depending on how big or small they are. So liquids have definite volume, but take the shape of the containers. So when you pour orange juice into a glass, it still takes up space, but it's going to take up the space depending on the shape and how big the container is. So for example, we have some beakers here with some food coloring in it, so we can see that there is volume in there from the liquid, but it's taking that circular shape of the container. And lastly, gases take the shape and volume of the containers that they are in. So in our last lesson, if you remember, we had talked about the hot air balloon. So we know that inside of that hot air balloon is the gases are going to take up that whole space inside of the hot air balloon. All right, so if you have a piece of paper in front of you, I want you to take that piece of paper and I want you to change it in some way. You can pick whatever way you would like. So I'm going to take just a regular sheet of paper here, and I'm going to choose to crumple it up. So we went from just a plain sheet of paper, and we made it into a crumpled up ball. All right, so first off, how did you change your piece of paper? So here's some examples of what you maybe tried doing. So maybe you took your sheet of paper and all you did was you folded it. So maybe you folded it this way, maybe you folded it this way. Maybe you took your sheet of paper and you tore it. And then like I did, I crumpled my sheet of paper. And maybe you just took your sheet of paper and you just bent it in some way. Or maybe you even took a pair of scissors, if you had one, and you physically cut your sheet of paper. All right, so after doing this, why are the changes that you made to the paper just physical changes? So we know that the paper is still paper and that you can unfold it. So we didn't make the paper into something else. All right, so physical change is often due to a change in temperature. So how do you think that heat affects physical changes. So I'll let you think about that for a second. So how do you think heat can affect physical changes? You can use even the pictures down here to maybe help you come up with your answer. So some types of matter change state when enough heat is added to it, and that's what we can call melting. So something that we can think of as melting is maybe the snow. So when it's cold enough for it to snow, so 32 degrees Fahrenheit or lower is when we'll have snow. But if all of a sudden now it's a 40-degree day, the snow is going to melt because there was enough heat that was added to it to make it melt. Or the opposite is when we take heat away from it, and that's when we get freezing. So for example, maybe when you put something in your freezer at home, so you bought it at the store, and maybe it was in the refrigerator at the grocery store, but your parents are like, we're not going to eat this right away, so we want it to last longer. So you'll put it into the freezer where it's even colder than the refrigerator. And so there we are taking away even more heat from that. And then also, just a little extra thing is that water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. So again, at 32 degrees Fahrenheit, that is when rain will turn into snow. That's the temperature point where rain will turn into snow. All right, so let's talk about what is a physical change. So here's just a bunch of examples that I will put up here for you. So crushing something, so maybe you take an aluminum can, maybe like a Pepsi can or something like that, and you put it underneath your foot and you stomp on it. So that's a physical change. You just crush the can. So folding is another example. So like before, we took our sheet of paper and we just folded it. So when we put that crease in there, we are physically changing the piece of paper. Also just bending a sheet of paper. So not actually putting that crease in there, but just bending it over. That can be a physical change also. Again, tearing is a physical change. I had one sheet of paper, and I still have a piece of paper, but now I have two pieces of that same piece of paper. So again, cutting. So I have a piece of paper, and now I cut it into two. So it's still a piece of paper, but now I have two pieces of that same piece of paper. So crumbling, so that's kind of like when before we had scrunched up the piece of paper. Sanding would be where we would take a very coarse piece of paper and we would rub it like against a piece of wood, and then we get that nice smooth finish on a piece of wood. And then also smashing, so that's kind of the same with like the crushing. So if we smash something, it's still the same thing, but we're making it look different than what it originally was. And then also peeling. So like maybe you've peeled potatoes before, so you take off that skin on the potato. It's still a potato, but you have changed how it looks. And then these ones over on the right side, the melting and freezing. These are still physical changes, but these ones are changing from one state of matter to another. So these ones, the items still are the same thing, whereas with melting and freezing, it changes from one state of matter to another. All right, so what are some physical properties of matter? We're going to go through this list here. So color, the texture, so how does it feel? Does it feel rough? Does it feel soft? Does it feel squishy? Also, odor can be a physical property of matter. So the size, again, we talked about the volume of something. So again, we bring up volume here along with that. And then also the mass, so how much does it weigh? And then remember, it can be a solid, a liquid, or a gas. And also something being magnetic, that can also be a physical property of matter. Also floating or sinking can be a physical property of matter that we can use. And then also boiling point. So this one we won't get into a whole lot right now, but that is still a physical property. The boiling point is when something changes between those different forms. And then also the melting point. So from when it goes from so for the boiling point, when it goes from like a liquid to a gas, and then with the melting point, that is the temperature at which a solid will melt. All right, so what are physical changes of matter? So a physical change is a change in the physical properties of matter. So the matter changed in how it looks, but what it is made out of does not change. So a change that takes place when a substance changes in size, shape, or form. So the particles of matter itself do not change. All right, so now we're going to just quickly look at chemical changes. So this is the opposite of a physical change. All right, so chemical changes produce new substances that have different properties than the original substances. So unlike the paper that we cut and we crumpled and we tore, this time with chemical changes, when an item goes through a chemical change, it's going to change into a completely new substance. So let's think of some examples of chemical changes. So burning something. So if we took this piece of paper and we burned it, is it still going to be a piece of paper? No, it actually is not. So that is an example of a chemical change. We are no longer going to have that piece of paper. So also rusting. So rusting happens when a piece of metal is left out in... So rusting is when something is left outside and it is exposed to the rain and wind and other elements. And rusting is when water sits on that metal and then it starts to decompose and it starts to give you that rusty burnt orange color. So here's an example. In this picture of a rusting, we kind of see inside these containers that have been left outside that they have changed color. So also cooking and baking. So this is one that we see all the time in our lives. So like if you're baking a cake, you start with your cake mix and your milk and your eggs and you mix it all together. But when you put it in the oven and it's done in 20 minutes, does it still look the same? So now when we take it out of the oven, we have a totally different looking product than what we started with. All right, and just real quick, Here's just some more examples on chemical changes. So fresh leaves and decaying leaves. So when they fall off of the tree, they no longer are getting the nutrients from the tree and they start to die. And we know that fresh leaves are going to be green, shows that they're healthy, they're getting the nutrients that they need. And decaying leaves are kind of more of a brownish orange color, telling us that they are drying up and dying. All right, so why do you think the leaves change? So remember that the leaves changed again because they have fallen off of the tree and they are no longer getting those nutrients. All right, so what are some examples of chemical properties? So we had talked about physical properties. Now we're going to look at some examples of chemical properties. So corrosion of a metal. So this is when iron combines with oxygen in the air and rust forms. And again, many times we also see rust from water that sits on iron or metal. Also gas bubbles. So baking soda combines with vinegar and then you end up getting what is called carbon dioxide. And then a change in color, so such as like a browning of fruit, which we could also call decay. So just like we saw in the last slide, we saw that those leaves were decaying. So an apple is peeled and the reaction with oxygen in the air is what makes apples brown so quickly. So chemical changes change the chemical nature and properties of substances to form new substances. So remember that physical and chemical properties are opposite of each other. All right, so what are some examples of evidence that a chemical change was what took place? So a change in odor, a change in color, a change in the taste, a change in the mass, so remember the weight, so forming bubbles, so giving off of a gas, so giving off smoke, giving off light. So these are all different examples of evidence that a chemical change was what took place with an object. All right, so let's just quickly compare and contrast property changes. All right, so physical change. So remember, a physical change is a change in the physical properties of matter. So the matter changed in how it looks, but what it is made out of does not change. So a change that takes place when a substance changes in size, shape, or form, and the particles of matter do not change. So that object still stays the same. All right, so now chemical change is a change in the chemical properties of matter. So a chemical change occurs when two or more kinds of matter combine to form a new substance with different properties. So a change that takes place when a substance is completely altered. So the particles in a chemical change do change. All right, and then we just have a quick video here on states of matter and changes of state.
Smile and learn. Ugh, it's so hot. Hey there, I'm making some strawberry popsicles. It's steaming hot today, and I really wanted to have one. But for them to stay solid, I'd have to put them in the freezer like these ones and wait for a while. Really? You don't know what a solid is? It's one of the states of matter. Don't worry, I'll tell you all about them right away. Matter, the substance all things are made of, exists in 3 states: liquid, like this strawberry juice, solid, like this popsicle, and gas, like the water vapor coming out of this pot. Everything we drink is in its liquid state. Matter, in its liquid state, takes on the shape of the container and its volume always stays the same. Particles are separated and can move freely. Can you see how they're moving? They look like they're dancing. The popsicles we eat are solid. Matter in its solid state is characterized by having a fixed shape and volume. Particles are held together in an organized structure. See? Lastly, the gaseous state. The vapor coming out of the pot is a gas. Matter in its gaseous state can change its volume and shape, taking up the space of its container. See? Particles are well separated and can move freely. Look, they move like crazy. Did you get the idea? Let's recap a little. Matter exists in 3 states: solid, liquid, and gas. Solid matter has a definite shape and volume. Particles are well organized and held closely together. Liquid matter takes on the shape of its container, occupying always the same space. Besides, particles are separated and can move freely. Gas matter doesn't have a fixed shape or volume. Its particles are well separated and can move freely. That is all about states of matter. Very interesting, isn't it? Well, I'm leaving now. I won't sell any popsicles if I don't. See you around.
That's it. Perfect. They'll be ready in no time. Hey there, I'm making some more popsicles to sell. They taste so good. I'm sure they'll sell really fast. These are ready. See? They've become solid because I put them in the freezer. Have you ever heard of the word solidification? It's one of the changes in states of matter. There are more changes, don't worry. I'll explain all about them. You already know that matter exists in 3 states: solid, liquid, and gas. A change in state happens when we heat or cool matter. If we heat solid matter, it becomes a liquid. We call this process fusion. If we heat liquid matter, it becomes a gas. We call this process vaporization. These 2 processes can occur the other way around. This happens when we cool matter instead of applying heat. If we cool a gas, it becomes a liquid. This process is called condensation. If we freeze liquid matter, it will become a solid. This process is called solidification. Oh no, the popsicles have melted. I completely forgot about them. Do you remember how we call the change from solid to liquid? Fusion. When a solid becomes a liquid, it's called fusion. When the temperature of a solid rises, the particles that make up matter start detaching from one another and move more freely. See? Liquid turns into gas when heated. Do you remember how we call this process? When a liquid becomes gas, it's called vaporization. When a liquid is heated, the bonds among the particles that make up matter become more loose, so particles move around freely. What if I cover this pot? What do you think might happen? Water vapor cools as it reaches the lid, and its state changes from gaseous to liquid. Do you remember how we call this process? I've just told you, haven't I? The change from gaseous to liquid is called condensation. As a gas cools, the particles that make up matter start coming closer to one another and move around more slowly. This will continue to happen till matter solidifies completely. I think the popsicles I froze up earlier are just about ready. That's right, I put some popsicle molds in the freezer a while ago. The liquid in the molds must have frozen up by now. The change from liquid to solid is called... Come on, you know this. I told you before. It's called solidification. During the solidification process, the particles that make up matter lay very close to one another and move less and less. These are the changes in the states of matter. Let's recap. If we heat solid matter, it becomes a liquid. We call this process fusion. If we heat liquid matter, it becomes a gas. We call this process vaporization. These two processes can occur the other way around. That happens when we cool matter instead of applying heat. If we cool a gas, it becomes a liquid. This process is called condensation. If we freeze liquid matter, it will become a solid. This process is called solidification. Now you know all about the changes in states of matter. I hope you find what you've learned useful in class. I have to go. Look at all those people lining up for popsicles. See you around!